Hello and welcome back to another episode of ABI Labs. In the previous episode, Oliver discussed how we can use the MIS4 to carry out a parametric test on the optocoupler we have. He also mentioned that we have a customer in Latin America who was having a problem with their trains. They were finding that there was a delay in the response from the door of the train to the driver. They were finding that the doors were opening when they were actually closed. Once they implemented the BoardMaster into the repair and maintenance department, they were carrying out a functional test using the AICT module, and this test was telling them whether the device was passing or failing. However, this test did not give them more detailed information like a parametric test would do. So in that case, they implemented the MIS4 that worked out the switching speed, the propagation delay of the optocoupler, which allowed them to find out which actual optocoupler was at fault. They've previously replacing all 40 optocouplers, but then they minimized this all the way down to the actual optocoupler that was failing, saving them a lot of time and money. So Oliver, can you explain how we can use the multi-way connector on the MIS4 to carry out further tests on our board?
Okay, so the last two instruments of the MIS4 is the universal I/O and auxiliary power supply, both coming from the multi-way connector. We do have a clip like this that comes off the MIS4 with all the multiple colours as well. So the multi-way connector can use two instruments with the MIS4. So those two instruments are the universal I/O and the auxiliary power supply. I'll show you the universal I/O here. So in this instrument, we've got 8 channels, all of them different colours, matching the cable I've got here. You can either set them to input, output, drive or sense, and you can either set them as high or low, and you can choose what high or low levels you want in the settings. So here, you can also choose the digital presets. Here we've got CMOS and TTL. You can also use analog presets such as 5 volts and 7.5 volts, and you can also choose custom levels. So with the instrument, you can either choose 8 channels, high, low, output or input. And then with the auxiliary power supply, we have 4 channels. We have one for positive up to positive 12 volts, one for negative 12 volts, one for positive 3.3 volts, and one for positive 5 volts.
That's great, Oliver. So that's 2 of the 8 instruments available with the MIS4.
Exactly. So in total, you've got an oscilloscope, waveform generator, frequency counter, your multimeters, your universal I/O, and your auxiliary power supply in one module.
So Oliver, in the previous episode, you showed us how we can test for the propagation delay on this optocoupler that we have. How about the CTR?
Okay, so for the CTR, the current transfer ratio test, another parametric test, it's very important to test that because for the propagation delay, we're testing the speed, and for the CTR, we're testing the intensity, as our friends in South America would say. So for this test, we'll be using the universal I/O and auxiliary power supply to test the device to see how much the device is boosting the current on the other end. So I'll open up on the other step, and with some coding we'll show in later, you can actually grab the current ratio from the optocoupler. And it also goes to show that you don't also need another board to test against. You can test against other devices in the same IC. So here we've got 2 optocouplers in our dual optocoupler, and we can see that it's the current transfer ratio for these 2 devices are 281% and 289%.
So that's really useful for predictive maintenance, because what we can do is we can test our component and see how our component is operating and whether it is degrading slowly. And this will allow us, by monitoring the propagation delay as well as the CTR, we can see whether our component is coming to the end of its life. And then obviously we can in time replace the component if necessary. So just to finish off with the optocoupler, Oliver has shown us how we can use the BoardMaster to do several different tests. So we began by checking for the propagation delay using the MIS4, and then we moved on to do a current transfer ratio test. Now what Oliver is going to show us is how we can use the AICT, yet again, which you can see in the previous episode, to carry out a functional test on our optocoupler.
Exactly. So using more of an automatic test, we'll now test the functionality of the optocoupler using the AICT module, which is as simple as opening up the analog IC tester in the AICT module, searching for our device, which is a TLP621. And there it is. This is the one we want, and it gives us a handy readout about the device, a dual coupled NPN phototransistor. And it gives us that DIL package. That's our IC there. Just need to hook onto the IC, as simple as that, and run the test. So this is a power off test, okay. Automatic clip positioning has been turned off, and it will give us a pass or a fail depending on the functionality of the device. There we go, got a pass, and it's done as we did before, the CRT ratio, and check that the device functions as it should.
Thank you, Oliver. So stay tuned for next week's episode, in which we will be looking at the remaining instruments available with the MIS4, so your voltmeter, ammeter, ohm meter, and frequency counter.